Hi everybody, in this video I will be showing you how to graph a quadratic function with non-integer x-intercepts. There are several steps to doing this, so let's go ahead and jump right in. Our function is m of k is equal to k squared minus 6k minus 1. When doing graphs of quadratics, the first thing that you want to go for is always the vertex. And the vertex is the most important point because it determines either the highest or the lowest point of this parabola. In this particular case, I already know that my parabola will be like a smile. And the reason is because my value for a, which is my coefficient over there, my a value is a 1. When it's 1, in other words, when it's greater than 0, your parabola will always face in that direction, okay? That's how I know that this vertex will end up being the lowest point. My b value would be the -6, and my c value would be the -1. So with that, I go ahead and jump into the vertex. My vertex will be given to me by x is equal to -b over 2a. This gives me only the x-coordinate of the vertex, which is actually an ordered pair, x comma y. So by substituting what I know about a and b, I get the following. This will be -6 over 2 times 1, which, when simplified, becomes 6 over 2, which is 3. Now 3 is only my x-coordinate. I still need to figure out the y. And to do that, I need to substitute my 3 back into the function and evaluate it. So what I get is m of 3 is equal to 3 squared minus 6 times 3 minus 1. This in turn gives me 9 minus 18 minus 1. And when that's all simplified, that's -10. Okay, so my coordinates are 3 and -10. Now, as you can see over here, my space is rather limited, so I'm going to have to change this just a bit. Instead of numbering this by ones, I'll have to number them by 2. So this will actually be 2, 4, 6, 8, 10, 12. And this will be, similarly, this will be -2, -4, -6, -8, -10, -12. Sorry, that looks a bit messy, but you get the idea. So this is 2, 4, 6, 8, 10, and -2, -4, -6, -8, -10, -12. I don't think I'll have to go out that far. Sometimes when you're doing graphs, you have to make adjustments to the coordinate plane, especially if you're given one. I got this off the internet, so 6 is as far as it went in all directions. Okay, so I can go ahead and plot that point. That point lies right over here. -3 and -10. 3 would be right here between 2 and 4, and -10 is all the way here. So this is 3, -10. This is my vertex. So 3, -10. The most important point of my parabola. The axis of symmetry is what's next, and the axis of symmetry is always going to be given by an equation starting with x, and the x value was already determined from number 1 when we got the vertex. The x value is a 3, as you saw from this little formula here. So I simply take that same number and apply it there, and this becomes the equation of a line which divides my parabola into 2 equal parts. So that will be at x is equal to 3, and that will be here. So let's see, I'll choose a different color. Right down like that. Okay? And I always like to write the equation of my line, so I know where it's coming from. This is x is equal to 3. Okay, so as you can see, it passes right through the vertex. And now I move on. The y-intercept is always my constant, which in this case is -1. So therefore, my y-intercept as an ordered pair would be 0, -1. So I can put that point as well. So 0, -1 would be right over here, 0, -1. Now, the beauty of the axis of symmetry is that it gives us a mirror or a reflection of whatever point you have on one side, because your axis of symmetry acts like a mirror. So it reflects anything that's on one side to give you something on the other side. So my y-intercept is here at 0, -1, and it is exactly 2 spaces away from that axis of symmetry. So the reflection of this point will be 2 spaces, but on the opposite side. In other words, this way. So I have to count. So it'll be, again, it's 1, or so basically 1.5 squares. So it'll be right here. So this is half a jump and then 1 full jump over here. Same level. There's my reflection. Okay. Now the x-intercepts. So the x-intercepts, I have to figure out where they are. And I know I'm going to have them because I know, like I said earlier, that my parabola will be something like that. And because I know that this is a vertex and these are 2 points above the vertex, this parabola is going to swing down, hit the vertex, curve, swing back up, hit the reflection of the y-intercept and keep going. And in swinging down and swinging back up, it'll pass through the x-axis in 2 places. And I need to know where they will be. Okay. Now, sometimes x-intercepts will not be at perfect locations, like the corner of a square. And for that reason, we may need to use a calculator. Now, technically, I could draw my parabola right now, but it would be a rough sketch. Okay, so let's see if we can get a better idea of how this will look. So the x-intercepts, I can use a quadratic formula, or I can try to factor it. Let's see, I'll use a quadratic formula, which is x is equal to -b plus minus square root b squared minus 4ac all over 2a. Knowing my a, b, and c values, I simply replace them into the formula, and I get -6 plus minus square root. This will be -6 squared minus 4 times 1 times -1 all over 2 times 1. And you just keep breaking this thing down. So this will be 6 plus minus radical 36 plus 4 all over 2. Now, what's happening here is I'm going to have to move this down. Oh, I didn't do it quite well enough. Let's see if I can do that again. Nope. All right, I'll have to erase it. So what I have to do is just keep simplifying this until I can't do it anymore. So this is 6 plus minus square root of 40 over 2. Now, the radical of a number will either be a perfect square, which is easy, or it will be an irrational number like this one over here, or it will be an imaginary number, which means that you have a negative number inside the radical. If that ever happens, that means you have no solution or no x-intercepts. But if it's not a negative number inside the radical, it means you will have at least one x-intercept. Okay? 2 at the maximum, 1 at the very least. So in this case, the square root of 40 is not a perfect square. And so I have to simplify this using my knowledge of simplifying radicals. So I think to myself, what 2 factors are there of 40 that I can break this into? And that would be, well, that would be radical 4 and radical 10. Okay, now radical 4 is a perfect square, so I get 6 plus minus 2 radical 10 all over 2. Now, what you can do from here, because this 6 and this 2 are both outside, and they're all being divided by a 2, and 2 divides into a 6, and it also divides into this 2, what I can do is I can divide 6 and 2 by 2. And that will simplify everything. So 6 divided by 2 is 3. Plus minus stays plus minus. 2 divided by 2 is 1. So I just get radical 10. And these are my x-intercepts, believe it or not. So one of them is located at 3 plus minus radical 10. And the other is located at 3 minus radical 10. Now, where these are exactly, well, you would need a calculator to figure this out. But the point is that you know you have x-intercepts, and there are two of them, one here and one there. The exact location is not as important in this case because I still have one opportunity left to give me nicer, clean points. And so if these radicals prevent me from putting a point exactly where I know it will be, then you move on to the next step, which is, do you need more points? And if the answer is yes, this is what I erased earlier. Need more points? And if the answer is yes, go to a table and get one or two more points if you can. Now, to figure out what input numbers to place in the table, you go to the graph that you have so far. Now, I know that so far I have a point on the right and left side, and this point over here is at 3, x equals 3. This point over here is at x equals 0. I might want to go with x equals -1, or x is equal to, excuse me, this is not x equals 3, this is x equals 6. So I might want to go with a point at either 7, or I might want to go with a point that's at -1, okay, or -2. Let's see what happens if we put a point at -1. So I'll put -1 here, and we'll figure out what we get. So this is 6 times -1 minus 1. This would be 1 plus 6 minus 1, and that would be 7 minus 1, which is 6. So my ordered pair is -1 and 6. So I go over to my coordinate plane, and I keep this place in mind, -1, comma 6, and I place a point there. So -1 is here, and then going up to 6, that's right here. Aha! -1, 6, there. And I have a point that's reflecting this one, but on the opposite side. Now this is half a jump, and then 1 square, and half a jump again. So I need to do the same thing, but on the other side. So half a jump, 1 square, half a jump again. Same level. Place my reflection point right there, and now I can make a nice, good curve of this parabola. I'm going to thicken this just a bit so I can get a better curve here, and you can see it better. And I'll switch to, let's see, purple. That would be a good color here. Okay, here we go. This is always the tricky part because, yeah, I already messed up. Here, let me try that again. So you want to go through the points you created. You want to swing at the bottom. Make sure that you don't make a letter V because it is supposed to be a curve. You swing, go up, 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 up. And you place arrows because this thing is technically infinite in its design. And there you have it. We have our parabola. Okay, the lowest point, the y-intercept, its reflection, an extra point, its reflection. And you can see that we have our y-intercept, or excuse me, our x-intercept is about right there and about right there, which does make sense if you think about our results over here. Does make sense that we would have one that's positive, one that would be rather negative, okay? So here we go. This is our parabola. Now we can write the domain and the range. The domain of, and I'll do this over here. The domain of a parabola like this that goes on infinitely will usually be all real numbers. And all this means is that as it goes infinitely upwards or infinitely down, it gets increasingly wide, right? So it's really narrow here, gets wider, wider, even wider over here. And it never stops getting wide because it never stops going up. And so eventually it will cover all the values along the x-axis, positives, negatives, 0, all decimals, all fractions in between the integers. So that's what all real numbers is. It's just all types of numbers. The range has to do with our y values. And because this parabola has a lowest point at -10, we have to represent that. This parabola has the lowest point at -10, and all the y values of this parabola increase from that point. So it gets as low as -10, but not any lower. And then from there, all the y values increase increase, increase as you go up. So for that reason, we put greater than or equal to. The equal